All right, good morning, everyone. Today is Thursday, October the 28th. All right, everyone ready for some review? Unit 3 review. Before we start, I do have a video to show you. Since Halloween is this coming Sunday, there's a house pretty close to me. So one of my neighbors, they go all out for Halloween and they decorate their house and they have a Nightmare Before Christmas theme and they keep it up like pretty much all of October, and then after Halloween they convert it to a Christmas theme, and then they still keep it up. So October, November, December, and they take it down sometime in January. It's very popular. It appears on a bunch of lists of places to visit for when you're trying to find houses to look at for the holidays that are well done. And this one is definitely well done. So let me show you that video. So Brady, you know where that house is at? Oh. And how do you know they give out full candy bars? Or are you just guessing? No, I don't know if you saw it, but in the background they have the Nightmare Before Christmas movie playing on a screen. Yeah. Yeah, when it gets closer to our break in December, I'll show you what it looks like when they have it converted to a Christmas theme. It's kind of nice. Okay, everyone got this first problem done. That is correct. So, given this type of problem on your test, what should you do first? What is all of you should do? Yeah, you should graph it, not distribute. You should graph it. You always want to graph these. You always want to graph these. Yeah, always graph it first. It's like Enzo says, so let me show you the graph. So if you graph this problem, you get something like this. And what Enzo says, if you notice, what's wrong with my mouse today? Hold on a second. I'm sorry. It's okay. When you graph it, you notice these are the two answers that you get. And if you see, we get two nice y value. You get, well, 2 and 2. When you graph it, if it gives you a nice number, it really cuts the problem in half, because if you know the y value for the answers, what do you just have to do? Yeah, you just plug in that y value into one of your equations and solve. So graphing it can reduce the problem by half. So if you know the y value is 2 from the graph, just plug it into one of your equations. And I thought the first one was the easiest, so I just plugged in that, and then we solve. And then that's how you get the x values. So we have -2 plus 2 rad 2 and -2 minus 2 rad 2 for the x value. And then the y values is 2, because that's what we plugged in. So that problem is actually rather easy if you approach it that way. You can skip the half of the work that involves finding um, the first variable. But if you did, like, so here's the work. If you did find the y value the algebraic way by using substitution. So if you notice, we have x plus 2 squared is equal to this. And then in this equation, we have x plus 2 squared. So all you got to do is replace this entire piece, x plus 2 squared, with what it equals. So this piece becomes 8 times y minus 1. Again, this piece became that, and then we just write everything else, and then we can solve for y. If you notice, we got 2, but we also got -8. And if you did it this way and you show the work for -8, you discover that you get imaginary solutions, and that's why. And that's why we don't include it. So remember, when you have your solutions to a system, you only want to include real solutions, not imaginary solutions. So that's why -8 for the y, and then your x values are not part of your solution set. Good stuff. Okay. What is the equation of a circle whose diameter is 6 and whose center is 4, -3? Try to quickly do this problem. But what should we do first? What's a good way to approach this problem? Yeah, write the equation of a circle. And maybe even draw a diagram. Anybody think about drawing a picture? So we have the diameter being 6. So if you draw that picture, from here to here, let's say that's the diameter. That's a distance of 6 units, right? Yeah, that's 6 units. So when you have the equation of a circle, we need the radius. So like what Enzo says, we just take that radius or that diameter, we cut it in half, and then that gives us the radius of 3. So from here to here is a distance of 3. And then 3 squared is 9. Remember, this is r squared, and radius is 3, r squared, so 3 squared is 9, and then there's your center. Straightforward. Okay, an ellipse. So we have, what are the lengths of the major and minor axes of the ellipse? Give me a second here. This is a commonly missed problem. Yeah, so maybe drawing a picture. So is this ellipse going to be vertical or horizontal? All right, so Brady says that pictures normally don't help you. It's going to help you here. Yeah, this one is going to be horizontal, and we know it's horizontal, well, because this 8 is bigger than the 6, so it's bigger in the x direction. All right, so from the center, we'll do the major axis first. From the center to this point, do we know that distance? So Enzo says 2 rad 2, Brady says 8. Brady, the previous problem, is this a radius of 9? It's not. Yeah. And these sort of act like radiuses. This is the radius, so to speak, for the major axis, and this is this the radius for the minor axis? Is it 8 and 6? Is it from here to here? Is that going to be a distance of 8 units? Yeah, it's a square root of 8. So remember, this is a squared, and this is b squared. So a is your major, b is your minor. So a is not 8. Okay. We have to do the square root of 8, which is 2 rad 2. So the radius, so to speak, for the major axis is 2 radical 2. And the question wants us to find the lengths of the major and minor axis. So if we know from the center to this major vertex is 2 rad 2, how do I find the full distance? Yeah, we multiply times 2. And 2 times 2 rad 2 gives us 4 rad 2. So this is a commonly missed problem. So I forgot to put a password on this test, and 2 people already took this test, and I think both people missed this problem. Or I know at least one did. And the second one may have gotten it right. I don't remember. But yeah, this you need to understand how the different parts of these different conics work, and drawing a picture like this, even though it seems like, oh, it's not going to help me, I promise you, the more work you show, the less mistakes you're going to make. So from here to here, we know that this is 2 rad 2. We just have to do the square root of these, and then we have to double it. So what's the minor axis then? Minor axis. Yeah, 2 radical 6. Yeah, 2 radical 6. Yep, square root of 6. And then we have to double it, so 2 rad 6. All right, eccentricity. This should not look new at all. If you are all doing what you're supposed to be doing in this class and actually going through the learn and practice modules and working out the examples, you would have come across problems that ask about eccentricity. I didn't teach it in class, but it was pretty simple to go in the module. I think it was in day 3 of ellipses, last page. And there's a formula. So the question says, how does the value of the eccentricity of the ellipse describe its shape? So here's the equation of the problem here. You have 2 choices. You can either determine that the eccentricity is more circular than elongated, or more elongated than circular. And I did include the snippet from the actual module. So the equation for eccentricity is E equals C over A. And this describes how circular an ellipse is. So if your E value that you find is closer to 0, then that tells us it is more round. If the E value is closer to 1, well, then it's more squished or more elongated. We all know that the C value is the distance from the center to your focus point. we know that the A value is the distance from the center to a major vertex. Your B value is the center to a minor vertex. So we could use this equation here if you actually knew these pieces. However, we don't know C directly without doing some math. So we have this other equation, and this is the one that you really want to use. You shouldn't use this because if you're given an equation, it gives you right away, it gives you B squared, it gives you A squared. You just got to plug those in. So class, tell me, looking at this equation, what does B squared equal? Yeah, B squared is definitely 6. Yeah, B squared is definitely 6. What does A squared equal? Yeah, 10. So remember, you guys, you should have at least these formulas in front of you and what they look like. So this is bigger than this one. So this is the major axis. So this is your 10 is equal to A squared. This is your minor length. So, or not your minor length, sorry, the minor axis. And this is your B squared. So all you gotta do is just plug in this case, you're gonna do 6 divided by 10 into that formula there. And don't forget to square root both sides. And hopefully all of you have a calculator and not on your computer, like an FX 300. Spend $10, buy one, invest in your future. You'll need one for next semester for sure. But you type it in, and if you have an FX model or a decent TI model, whatever, it should have math print. Hit the square root button, hit the 1, hit the minus button, hit the fraction button. You'll have a cursor top and bottom, enter the 6, enter the 10, hit enter, and it'll give you a decimal. So class, tell me, is the answer A or B? The answer is B. It is definitely more elongated than circular because it is closer to 1. So if it's closer to 1, then it's, well, more squished or it's more elongated. So yeah, the answer is B. And you should have seen a problem like this in your module, so nothing new. All right, hyperbola. So the center of a hyperbola is -1, -2. The length of the conjugate axis is 8, and the length of the transverse axis is 6. The transverse axis is parallel to the y-axis. What is the equation of the hyperbola in standard form? So, very straightforward. Based on the wording, is this going to be a vertical or horizontal hyperbola? It's vertical. And we know it's vertical because, well, it tells us. It says the transverse axis is parallel to the y-axis. That is telling us it is vertical and not horizontal. We just do a little picture to kind of represent that. All right, so we have we have our hyperbola equation equals 1. Which stuff is first, the x stuff or the y stuff? Yeah, the y stuff. Well, because it opens up and down. That's how we know that. And because we know the y stuff is first, we can actually just go ahead and pull out h and k. So we're going to have, what is that, y plus 2, and then x plus 1. All right. It says that the length of the conjugate axis is 8, and the length of the transverse axis is 6. All right, with that said, what number should go on the bottom here? Any ideas? So what number goes here? So we got an 8, we got a 9, got another 9, or 16. We're not really sure yet. So this is why pictures are good. One of you is correct. All right, so given our center being right here, did I hit? I'm recording this, right? Okay, I am. Just making sure. It says the transverse axis is a length of 6. That is the entire length. So that means from vertex to vertex, that is a length of 6. Remember, this right here, this is going to be your a squared. So what does a equal? What does a equal? Yeah, a is 3. So half of the distance, half of 6 is 3. So from center to this major vertex, this is a length of 3. So that's your a value. So a equals 3. So 3 squared is 9. And then it tells you your conjugate axis has a length of, what was it? A length of 8. So from like, I don't know, from here to, we'll say here. So from there to there, this is a length of 8. So that means, what is our b value? Yeah, b is just half of 8, which is 4. So that means that b squared gives us 16. Draw pictures. It does make everything so much easier when you draw pictures, and then graph it. So once you have your answer, graph it and see if what you have on the graph makes sense. You know, this should all make sense. If you happen to put like a, I don't know, like a 6 here or a 36 here, or you put like a 64 or an 8 here, and you graph it, if you kind of look at like just counting units away, it wouldn't make sense. How's it open up and down again? So yeah, so remember this. So from the center to a vertex, that is your that's always your transverse axis. So when it tells us the transverse axis is parallel to the y-axis, it's telling us here's your y-axis, and from here to here is your transverse axis length, which is parallel to the y-axis. So that's why it opens up and down. All right, more hyperbolas. What is the coordinate of the foci of the hyperbola? So on the side here, I did include the formula. Don't assume that what you have here is going to be a horizontal. Now, given this equation, is this going to be a vertical or a horizontal hyperbola? Yeah, it is horizontal. This one is at least. So still draw pictures, guys. This unit, if you draw diagrams, it will save you. I hate for all of you to forego diagrams because you think that you know it oh so well, and maybe you do. You just make simple mistakes because you don't draw a diagram. So there's the center, and we want to know these coordinates, your focal points. So based on this diagram, to find your distance of C, we need to know what A and B are. Do we know what A and B are? Or sorry, yeah, A or B, or do we know what A squared and B squared are? Let's start there. Yeah, we do. What does A squared equal? Yeah, A squared is equal to 4. B squared is then equal to 12. And there's really no need to actually find what A and B are, because when you use the formula, the Pythagorean theorem, will be squaring them anyway. So by actually finding the square root of 4 and square root of 12, you're going backwards because we're just going to end up squaring them anyway. So we'll just keep them in that form. And because we want to solve for c squared. And we can really just kind of do this in our head now that we have these written down. So we have a squared is 4, b squared is 12. 4 plus 12 gives us 16. So that means c squared is 16. And the square root of 16 gives us 4. Technically, it is plus or minus, but a, b, and c are always positive. So that's why it's just positive 4, not plus or minus. All right. Now, how do we find the actual coordinates? So how do we find the coordinates of these focal points? Yeah, we add or subtract from the center. Yeah. So are we adding to the x or adding to the y value? Yeah, the x. So we're just going to do -3 minus 4 and -3 plus 4 to get the x coordinates of the two focal points. The y coordinate is always going to be 4, obviously, because we're going left and right, not up and down. So yeah, pretty straightforward. Diagrams are great. Oh yeah, and then our center, we already know it's -3, 4. All right, parabolas. If I didn't tell you it was a parabola, we know it's a parabola because only one of our variables is squared. See, x squared. So definitely a parabola. So just quickly going through this should be really familiar. We have to move the y and the constant to the other side and keep everything else on the left. We then have to complete the square. So we do -14. I'll write it down. We'll have to do -14 divided by 2 is equal to -7. And then we have to square it, which gives us 49. So we're going to add 49 to both sides. And then we have to factor the left side and combine like terms on the right side. And then our last step to put in standard form is to factor out that -2. And then we have the answer. Pretty simple. All right. It's like circles. So we have to graph this. What's the center and what's the radius, class? -2, 3. And the radius you said was 3. So all I gotta do is just go to the graph and just plot these points. So we're gonna plot the center, and hopefully you plot this. So the only way you're gonna miss this problem is if you don't know how to plot a point. So -2, 3, and then we use the radius. So we do points right 3, left 3, up 3, down 3, and then there's your circle. I think this is a freebie. Hopefully nobody misses this problem. Word problems, yay. Okay, blueprints for backyard is a rectangle with vertices 0, 0, 50, 0, 0, 100, and 50, 100. The backyard measures 100 feet by 200 feet. We have a circular garden is at the center with a radius of 20 feet. What is the equation of the garden? Again, diagrams will make this so much easier. Yeah, so here's my backyard. And then let's label these. So we have 0, 0. Here's 50, 0, and here's 0, 100, and then here's 50, 100. And then this is going to be our side of 100 feet, which means the longer side is our 200 feet. What do you notice about this that's kind of, I don't know, I'm not, I don't know, off or tricky? Just tricky or what you notice? Yeah, so it's not a one-to-one scale. So if you notice, um, 0 to 50 comma 0, this is 50 units. However, the distance is 100 feet. So what does that tell you? How many units or how many feet per unit? Yeah, so 1 unit is equal to 2 feet. Yeah, so I'm going to write that down because that is important. I'm going to write there is 1 unit per 2 feet. So I'm going to write mine like that. So 1 unit per 2 feet. Which makes sense because from 0 to 100, well, that's 100 units, but it's 200 feet. So we just multiply times 2 to get the feet. All right, now we have a circular garden is at the center with a radius of 20 feet. So I'm just going to put a dot in the very center of my backyard there. All right, how do I find the equation of this circle? And of course, we're going to have the radius of um, what is that? What did we say? It was 20 feet. 20 feet. How do we find? How do we find this? Yeah, midpoint formula to the center point. Sure. So midpoint from like which corner to which corner. So how do I find that? Diagonal corners. Yes. So we could use this coordinate and this coordinate. We draw a straight line and we find the midpoint using those two coordinates, or I could use this coordinate and this coordinate to find the midpoint. However you want to do it, or we can just like look at it and figure it out. So the center. So from 0 to 50, what's the midpoint from 0 to 50? 25, yeah. And then from 0 to 100, what's the midpoint from 0 to 100? Yeah, 0 comma, yeah, I'm sorry, not 0 comma 50. So 25 comma 50 would be the center of our rectangular backyard. So you don't have to use the midpoint formula unless you really want to. You'll get the answer the same way. So we get so we fill that in, and we get that. So 25 comma 50. So there's that part of the equation. And then what is it going to equal? I'm so happy we're going through this because all of you would miss this problem. The equation is in units. The word problem gives you it in feet. Yep, you're still all wrong. Yep, still all wrong. All right, Isaiah. Isaiah got it right. All right. So remember, for a circle, right? It equals r squared. The radius of the garden is in 20 feet. The equation is in units. You cannot take this 20 and say 20 squared and then just do the math to get 400. It doesn't work that way. You have to convert feet into units, and that's why we wrote it down right here. Didn't you guys do this stuff in geometry, dealing with real world stuff? And no, yeah, okay, maybe we forgot. COVID cut it short. Yikes. All right. Geometry is too. Okay. All right. Well, remember, guys, when you have equations, it has to be the same units. So we're talking about units, not feet. So yeah, be careful. So 20 feet. So that's why it's 10 and not 20. And I like stoichiometry. Hopefully you all do too. But we need to convert this. So we multiply it times 20 feet um, equals. So feet and feet cancel out. And then 1 over 2 times 20 gives us 20 units. See how I did that? Or you can just say, well, I can just divide by 2 because it makes sense, I guess. So 10 squared gives us 100. All right. Fun stuff. You can also like maybe on your paper, so or in Desmos, plot these points to kind of show you the border of your backyard, and then graph this. And I'll tell you what, if you don't have a circle, if you don't have a circle at the center of your garden, and if your circle is greater than the boundaries of your backyard, you messed up. Brady, we cut it in half because this is in feet. Okay, this is in feet, but coordinates for the equation are in units. So from zero, sorry, from 0 to 50, that's units. See, this is 100 feet. So we have to divide, we have to cut this in half because it's 2 feet per unit. So 100 feet divided by 2 is 50. That's 50 units from here to here. Same thing for here. This is 200 feet from here to here, but it's 0 to 100. It's 100 units, which is 200 feet. So we have to take our feet, divide by 2 to convert it into units. So 200 divided by 2 is 100. So that makes sense. From here to here is 100 units. So from the center to one of your, like a point on the edge of the circle, this is 20 feet. So we have to cut it in half like we did these to convert it into units. So that's 10 units on the blueprint. Yeah, our equation is for units, not for feet. And if you square 20, you would have this is a unit of measure on the coordinate system. This is a unit of measure. And if you put 20 squared, you have feet as the unit of measure and not actual units. All right. And there's no other way that I can really explain it other than that. All right, next problem, ellipses. So general to standard. So given this problem, we know it's an ellipse because we have squared and squared, both of them positive, and they have different coefficients. So if I didn't tell you it was an ellipse, that's how you know. All right, so we have to group our x's, group our y's together. Then we have to factor out this 9 from the grouping of y's. The x's are good to go for our complete the square. So we take that 16, we divide by 2, and then we square it, and we get 64. So we are adding 64 to both sides. We are then taking that negative 10, we're dividing by 2, and then we are squaring it, and that's how we get 25. So we're adding 25 here, but don't forget, we're not just adding 25, we're adding 25 times 9 to both sides. So this number is what, that 225? We're actually adding 225. And then we combine like terms on the right side, and we have to factor the groupings on the left to get down to that. And then our last step is to divide everything by 36. And then that's how we get to the final answer. All right, Brady, let me go back to this last question and to answer it. All right. Equations of your conics are always in units. When you have a word problem and they give you stuff in feet, you need to convert them. So the vertices are given to you in units and not feet. Okay, that's why these weren't converted, because it was giving you this in unit. And this blueprint on our paper is showing that the distance from here to here is 200 feet, or also known as 100 units. 100 units. U for units. Because from 0 to 100 is 100 units. And then left to right, 100 feet to units is 50 units. So when this, remember, this is all in units. None of these numbers should be in feet. So if you have units, and you put 20 here, 20 squared, that's feet. So you have to convert this 20 feet into units by, well, dividing it by 2, because every unit, every single tick mark on our graph paper is 2 feet. So we divide that, so this becomes a radius of 10 units. That's how you decide. Everything must be in terms of units, not in terms of feet, inches, miles, or whatever, kilometers. All right. Yeah, and there's no other way to explain. Yeah, so the radius is 10, so it's 10 squared, which is 100. All right, okay, let's go on. Okay, this problem, hyperbola. What is the equation of the asymptotes of the hyperbola? Well, I give you this nice little cheat sheet over here about vertical and horizontal hyperbolas. I'm looking at this hyperbola. Is this one vertical or horizontal? Yeah, it's horizontal because the x stuff is first. So we're definitely going to use the horizontal stuff. All right, what does a squared equal? A squared is 4, and b squared is 9. So that means that a is equal to 2 and b is equal to 3. And then we know the center is -3, 4. That's super easy, which means our h value is -3 and our k value is 4. So if you just write all the stuff out and you write down what we need, we could just now at this point go over to the formula and just plug everything in. So we know the k value. The k value is 4. We know the h value, that is -3. We know our b value. Our b value is 3. And then we know the a value is 2. So we just fill that stuff in. And then we have our answer. Super straightforward. And of course, make sure you simplify if you need to. Does it matter whether the k is on the right or left? It sure does. It sure does. When you look at, so on your test, I think it's going to be fill in the blank, and I think they want you to enter your answer like this. And I think on the modules, when you did your quizzes, it wanted the same thing. I think this is how they wanted the answer, so that's why I boxed it. So it's not going to let you enter your answer like this, because it's going to have fill in the blank. All right, what is the equation of a circle whose endpoints of diameter are these two? So again, I think drawing a picture is always fun to do. Then we have two endpoints. So we'll just say we have an endpoint here. We have an endpoint over here. And how do you find the center given two endpoints? Yeah, we just use the midpoint formula, and hopefully you have that written down somewhere. But yeah, so we use the midpoint formula. So we add the x's divided by 2, we add the y's divided by 2, and we simplify. And for this problem, we have, we do have a fraction for the x value, and that can happen. All right, to find the radius, as I spoiled the surprise, we have to use the distance formula. So we have two choices. We can use our newly found midpoint to use the distance from midpoint to one of our coordinates. I would probably not do that just because, look, we have a fraction in the midpoint or for our center. And using a fraction in our distance formula, probably not always the most fun. So just use the distance of your two endpoints. And then once you find the distance, don't forget to do what to it? Yeah, cut it in half. So I'm just going to quickly show the math to get to there. So we get the distance being the square root of 181, and that does not simplify any further. So we leave it as such. Remember, guys, do not round your answers. In pre-calc, you don't want to have rounded solutions. You do that, it's a good way for me to mark everything wrong, or the test or the quizzes to do the same thing. We don't round numbers in this class unless otherwise stated. And there are situations when we do round, which we actually do round next semester quite a bit, and we'll talk about that when we get there. But anyway, radical 181 divided by 2 is the radius. So when you create your equation, we're going to have your x minus 3 over 2 squared plus y minus 3 squared. And then remember, it equals r squared. So you have to take the radius, and you have to square it. Don't forget to do this part. And when you square a fraction, you're squaring the top and the bottom separately. Or you just type it in and hit enter in your calculator, and it should, if you have like an FX300 or 115 model, it'll tell you the answer, and it will give you that 181 over 4. And make sure you simplify it, which it already is simplified. So that is your final answer. No decimals. All right. Parabolas. What is the equation of a parabola in standard form given the directrix is x equals -4 and the vertex is 3, -2? What should we do to start this problem? Yeah, draw it. Yeah, always draw a diagram if you can. It'll help you. So the directrix is x equals -4, so that is a vertical line. And then it gives us a vertex at 3, -2. So is that point to the left or to the right of that directrix? Yeah, definitely to the right. Yeah, 3 is definitely greater than -4. So I'm just going to put a point right here. So that is your vertex. So how does this parabola open? It opens to the right. Goes away from the directrix. So that makes sense. Okay. All right. So we know that. All right. We also know the vertex. It's given to us. We know it opens to the right based on a little picture we drew. What is our p-value then? And don't forget, your p-value is the distance from your directrix to your vertex. It's also the distance from your vertex to your focus, but not important right now. Yeah, the p-value is 7, and you could easily calculate that by doing the absolute value of -4 minus 3, so you'll get 7 as your answer. Remember, p is always positive, so 4p, 4 times 7 is 28. All right, with that said, you can just now create the parabola. We know that this is a positive x direction. It opens to the right based on our image here. Remember, this number in front is always 4p. That's why we had to find 4p. And then there's your h, and then there's your k. And this side is squared because it's a parabola. So, all right, pretty simple, straightforward. All right, ellipses. So the center of an ellipse is -6, 8. One focus is -3, 8. One vertex is -11, 8. What is the equation in standard form? Again, draw a diagram to show this stuff. So I went ahead and I actually used graph paper or my screen here, and I plotted these points, and we also want to label them. So -6, 8. So make sure I get that right. 1, 2, 3, 4, 5, 6. So that means that this is the center of the ellipse. And then it says one focus is -3, 8. So that is this point. There's your focus. And then one vertex. Okay, so there's your vertex. All right, so based on our points, is this going to be an ellipse that is a horizontal or a vertical equation? Yeah, it's horizontal because the y stays the same, and we can see there's a center, there's a focus, so it's definitely a horizontal. The focus only appears in the line. So in this case, it's in the same. It's in line with these 3 points, which tells us it is horizontal. I don't know if that even made sense what I just said, but you all understand, right? What I'm trying to say. All right. Yeah, hopefully we're on the same page. All right, then we can find plotting these points, we can easily find our a value. So what is the a value of this? Yeah, it's 5. So the a value is the distance from your center to a major vertex. So that distance is a distance of 5 units. And then what's our c value? What does that equal? 3. Yeah, so your c is the distance from the center to a focus point. We can just count that right on the graph, or we can just use a distance formula either way. And then we need to find the b value. And we're going to use, I included this to kind of show you the formula. And to find b, we're going to use c squared plus b squared equals a squared. So we use that formula. And we just plug everything in, and we get b equals 4. So now we can actually create the equation. We have x plus 6 squared, and then y minus 8 squared, h and k. We know that since this is a horizontal, the a value is 5, so 5 squared is 25. We know the b value is 3, so 3 squared is typo. Oh, I'm sorry, that's c. B is over here. B squared, so 4 squared is 16. There we go. And then equals 1, of course. Yeah, so yeah, Pythagorean theorem. So, but remember, A, B, and C mean different things. C is your focus distance. B is your semi-minor axis distance. And then A is your semi-major axis distance. And A so happens to be the distance from the focus to your minor vertices. So we talked about this already, and that's why it's b squared or c squared first. So c squared plus b squared equals a squared. Yeah, with hyperbola, it's normal, correct? Yep. Yeah, just know that the Pythagorean theorem is just leg squared plus leg squared equals hypotenuse squared. And we just so happen to call that just A, B, and C. Anyway, that was bell work. We already did it. I'm going to skip it. We did that already. Skip it. Okay, TGA. Am I good on time? Oh, yeah, I got 5 minutes. Okay. Whew. Your TGA is probably it's probably the hardest TGA of the semester, I think. But my goal is to make it a little easier for you. So we're going to talk about the questions because they're all. This is the easiest one right here. So on this one, you given an ellipse. I want you to find the center. So we have to graph it. Don't forget to graph it. We got to graph it. I want you to name the center, the endpoints of the major axis, the endpoints of the minor axis, and the foci of the ellipses. So label everything. And I should see the coordinates and everything on your graph. Show work, no credit. And then here's my little grading rubric. So if you hit all these points, or you'll get full credit. Pretty easy, super straightforward. Let's go on. And yes, you can use Desmos. Just make sure everything is labeled accordingly. All right, word problem. Number 2. LORAN is a long-range hyperbolic navigation system. Suppose 2 LORAN transmitters are located at the coordinates -100, 0 and 100, 0, where unit distance of the coordinate plane is measured in miles. That's really nice. It's a 1-to-1 scale. 1 unit is 1 mile, so there's no conversion needed like that garden problem. A receiver is located somewhere in the first quadrant. So I did label my quadrants, and we did talk about this in class before. We have quadrant 1, quadrant 2, quadrant 3, quadrant 4. So this one says that a receiver is located somewhere in the first quadrant. The receiver computes that the difference in the distances from the receiver to these transmitters is 180 miles. Second part says, what is the standard form of the hyperbola that the receiver sits on if the transmitters behave as foci of the hyperbola? So that's important. So it talks about up here, like the distance, like the difference to these transmitters is 180 miles, and it tells you those transmitters act as the foci points of the hyperbola. Sounds super easy, right? So I'm going to give you a push in the right direction and answer your question there. So we have the center. Here's our 2 foci points. Okay, there's the 2 foci points of the hyperbola. So the transmitters are located. Remember the transmitters are located at these coordinates, and it tells us that these transmitters are the foci of the hyperbola. So these coordinates are the foci. Okay. So we got to kind of jump around back and forth to really understand which part is which part. Label stuff. And I'm giving you a really big push here by putting the focus. This is the transmitters. And then it does tell us that a receiver is located in quadrant 1, and the receiver is in the line of the hyperbola. So we'll call this, like, this receiver is like some satellite in space or something. I don't know, that lies on this line here, this curve. But anyway, so I did talk about this in, like, I don't know, day 1 or day 2 of hyperbolas, and in your module they do talk about this little math principle about hyperbolas, that any points on your parabola, for example this point right here, any points, so the difference, remember difference means subtraction, so the difference of this distance and this distance is equal to 2a. So if I knew this distance and then I subtract this distance, that is equal to 2a. Is that clear? Now going back to this word problem, it tells you right here, The receiver computes that the difference in the distances from the receiver to these transmitters, also known as the foci points, is 180 miles. So, class, with that said, what does 2a equal to? All right, let me go over this again. All right. All right, this little math principle right here says that given a point anywhere on here, the difference of these two distances is equal to 2a. So if you happen to individually, you said, all right, let's calculate this distance and let's write that number down. And then let's calculate this distance to this foci point, and let's write that down. And then I have these two numbers, these two distances, and I say the big one minus the smaller distance, and I hit enter. The answer it gives you is 2a. So going back to the word problem, it says the receiver computes that the difference in the distances from the receiver to these transmitters is 180 miles. So it's telling you that the difference of these distances is 180 miles. So what does 2a equal to? There we go. Yeah, so 2a is 180. They are telling you that 2a is equal to 180. So we essentially know how to find what a is equal to. That is the big push I'm giving you. I will let you figure out the rest. I'm not going to say any more. I gave a lot of the problem away by going through this, but this problem is super confusing, and I would be very impressed if one of you were able to actually do this problem without trying to Google this word problem to find an example, which is considered cheating, by the way. I would be very impressed if you were able to do this problem without any help whatsoever. When I first read it, I'm like, what a really good question, but also what a very difficult question. So helping you out here. It's very complicated, very, very complicated. Yeah. So anyway, let's go on to the next question. Also kind of a difficult question. So again, I'm going to give you a really big push in the right direction on this one. It says a radio telescope has a parabolic dish. Radio signals are collected at the foci, or the focal point, called the focus, of the parabola. The distance from the vertex of the parabolic dish to the focus is 20 feet. Okay. The vertex of the dish is located at a point 30 feet above the ground and 80 feet to the east of a computer that reads and records data from the telescope. The diameter of the dish is 120 feet. What is the depth of the parabolic dish? All right, so I'm going to kind of give you a little push. So this is my sweet drawing of a parabolic dish pointed at the stars. And then here's my 2D representation of that dish. Well, we have we have it pointing up at the stars or whatever, at the satellite or whatever it's pointing to. It's to the east. So here's a vertex. There's our focus point that collects the data. There's the tips of the dish, and then obviously from the top of the dish to the bottom of the dish, that is the depth. That's why I have this labeled as depth. And then we all know that from edge to edge is a diameter, from halfway to one point is a radius. So this right here, having this labeled and me telling you, just assume that it's pointing straight up. It'll make your life a lot easier. Um, and then, given this information, you should be able to kind of label everything to figure out all the parts. To remember, our goal in this problem is to find the depth. So, guys, make sure when you answer your TGAs, you answer the question that's being asked. I don't ask you to find the equation of this hyperbola, though you may do that in order to get to this final conclusion. You might actually just happen to derive it, not because you have to, but because you need to. But the final answer says, what's the depth of this parabolic dish? So, and I also included the rubric to make sure that that you hit every single point if you want full credit. So make sure you do this. By the way, these questions 1, 2, and 3 will probably not be the same questions on the TGA. I have not uploaded the questions yet. I'm going to change some of the numbers to make it a little different. Both trying to minimize cheating. Yeah, so that should be a pretty big push in the right direction for numbers 2 and 3. And draw pictures. And by the way, your TGA, you need to, I want to see handwritten stuff. I do not want to see anything typed out. So 1, 2, and 3, do not type your work out. I want to see handwritten work. I want to see your flow of thinking of what you're doing. I don't want you to take your handwritten work and rewrite it to be all clean and neat. I want to see the mess that is you thinking on how to do this problem. I want to see that. And then I want to see, obviously, your right answer. You circle it, highlight it, whatever, to say, hey, this is my final answer. So make sure you do that to show, here's my work, and then this is what I boxed because this is my final answer. All right, like it says here, so attaching your work in a single PDF file. Please don't upload more than one file. You need to drop your images, your work into a blank Word document or the actual Part 2 document. Make sure the images are not blurry. This is a big one. A lot of you are uploading like super blurry pictures. If I can't see it, I can't grade it. Make sure it's easy to see and rotated properly. Don't put your images sideways. So put it in a Word document. Make sure they're nice and big. Basically one image per page, and save it as a PDF. So in Word, file, save as, select PDF. Also keep a copy of the Word document, for your own records, or you have to go back and look at it or whatever. Upload the PDF to be graded. Many of you are doing this already, so thank you. And remember, no work, no credit. And I'm really big on that. If I see your submission and you are lacking work, because I promise you, I read everyone's work start to finish. I don't just glance at it. I look at it. And if you do a problem differently of how I would have done it, I will go through your work to make sure it makes sense, and I will work it out myself. Because if your work doesn't match your answer, automatically I say you cheated, because your answer should match the work that you have, and if you don't, it's super sus. Which hopefully you understand that logic, right? And I have seen that on TGAs. You have the right answer, but your work makes 0 sense. If that happens, you cheated. I'm marking it all wrong. So you better be careful. I do read the work and I do comment. So can you include the TGA in Word doc so that we can paste Desmos? Yes, I will upload both the PDF and the Word document for you to do that. Just make sure that you save as a PDF when you upload it. And the reason why we have to do that is because when you upload your Word, if you upload the Word document, a lot of times that if you go back and you click it to verify it uploaded and it displays it, it doesn't display it right. In fact, it may be a blank document. It may have like question marks a bunch of places. It's just super weird. PDF is a sure way that it displays properly for me. All right, let me show the Sorry, I was reading chat. There's the password to the review or the test. Don't forget, you have tomorrow to do part 1, and then you have Monday to do part 2. And then we are starting Unit 4 on Tuesday next week. All right, guys. Well, thanks for coming, and I hope you reviewed something and you learned something. Well, not really learned something, just reviewed something because nothing was new today. All right, good luck. And if you need help, message me. Any questions, I'm available, preferably via Skype because that's the fastest way that I'll respond. You can also email me, call me, or text me. All right. Everyone take care. Happy Halloween.